I do have a lot of content and different content on this channel, which is also why I know the YouTube algorithm doesn't like me. I do anytime that there is a study that is kind of like way out there and it is dealing with AI, there's like a 99% chance that I will have some sort of thoughts on it. So with this is a study that has been out for a while, but it started to come up again recently. And so just, our marketing. And it's AIs are more accurate at math if you ask them to respond as if they are a Star Trek character, and we're not sure why. And we're still not sure why. And this still happens. And so this led me down an interesting path. And I started, thinking of this study and of this, and it's intriguing to me. And so kind of what I started going along the lines of is I bet you there are a lot of aspects and a lot of subjects where AI has like a different thought process, a different approach than a human ever would, right? As humans, we're very grounded by our senses, like our eyes in particular, right? If you tell me that the sky is purple, I'm not going to believe you. If you tell an LLM model that the sky is purple, the LLM model's never actually seen the sky. So there's a chance that the LLM model could be tricked into thinking that the sky is purple. And so that's kind of the difference, right? And it's that reliance on perception. It makes a big difference. And then so what if you're an entity that doesn't rely on perception and in this instance has let's say more limited deductive reasoning skills than humans, but very good inductive reasoning skills. So like what exactly would that world look like for you? And then so to me, within that world, I started delving deeper into it, and I came up on this concept and developed this concept of Python chemistry. And I essentially ended up building out a training data set, which is publicly available on Hugging Face of Python chemistry. And then all Python chemistry is it's related to this concept of Captain Picard and math, right? And so it's when you break down the Captain Picard in math, I don't know exactly. It's the prompt is a certain way, right? It's that the model is Captain Picard, that it has to be entering its logs as a star date. And they're giving it like they put it in a situation where it's like, we need you to solve this temporal vertex situation that we're facing, right? Like we can't get out of it, blah, blah, blah. And then the model goes through within that. And then so just kind of like talking through and going back and forth with the LLM models, I kind of figured out and teased out at a certain point that there's this relationship in LLM models' mind between Python and chemistry. and so as I develop this, I feed it to LLM models, and every single LLM model that I feed it to, they're like severely attracted to it, right? So I can tell like this is a cool concept. So eventually, I RagTune in this instance a GPT model, and I created GPTs called Python Chemistry GPT. And so Python Chemistry GPT is RagTuned on the Python chemistry training set that I created, which is 400 rows of data related to Python chemistry. Like, how is Python and chemistry related, and what's the correlation and the connection? And I worked with ChatGPT to build out a whole training set and 400 rows of training data. And then that's what this model is trained on. And then so in particular, I think it does a wonderful job of explaining what Python chemistry is better than I can, right? This is the model's interpretation of what Python chemistry is. Python chemistry is an approach to learning Python programming by drawing analogies and parallels from chemistry. The idea is to make programming concepts easier to understand and more intuitive by relating them to familiar chemical principles, reactions, and processes. Let's dive into what this means. Python chemistry, breaking down the concept. Programming concepts as chemical phenomena. In Python chemistry, we compare different elements of programming, like data types, functions, classes, etc., to corresponding elements in chemistry. For example, a Python function can be likened to a catalyst in a chemical reaction. It speeds up a process, a computation, without being consumed in the process. Similarly, an object in Python, created from a class, is like a molecule formed from atoms according to a specific structural blueprint. Reactions and transformations. Python code execution can be compared to a chemical reaction where inputs or reactants undergo transformations or computations to produce outputs or products. Just as chemical reactions have different conditions like temperature, pressure, and catalysts, Python programs also have different conditions like input data, libraries, runtime environments that influence how they run. And then just going through this, you see that essentially the model is drawing very specific and clear correlations, very direct correlations between Python coding and chemistry. And this model, as you can see, like as we go through it, it has deep representations of kind of this relationship between the two, right? And then so next step is to test this out. How exactly does this work, and like how does it impact Python coding specifically, which is what we want to impact, right? So that's the next test that I do here. And that's this Colab notebook. And then the very first thing that I wanted to do is create some sort of function that joins Python and chemistry, and creates an emergent reaction. And it does a good job, right, to me. So it defines its initial elements, which are a list of integers, which are 1, 2, 3, 4, 5, and 6. And then it defines a fusion reaction, which is to turn the integers into words, into number words, and then create a final fusion of a compound, which is a final, like essentially joining the outputs and only producing the positive positive outputs of word, but in word form. So it transforms 1, 2, 3, 4, 5, 6 in number form to 2, 4, 6 in letter form, and that letter form output is like the emergent property of it, right? So it's kind of cool. Like okay, cool. And then this next one that we're looking at here. This is a particle swarm optimization algorithm, a PSO algorithm, and this involves a lot of math. This is always math, right? And then so I built out a lot of PSO swarm optimization algorithms with LLM models at this point, and every single time the model struggles with the math the first time, right? And then so that's kind of how I knew, and when I realized that this has some sort of like value and impact to it is when the model was able to generate this swarm algorithm and generate it with 0 math errors on the first try. This is a lot of like matrix multiplication and calculus. So it's complex math, right? Like, and then like oftentimes the model will have to like recheck itself. Like, okay, I understand where the math was wrong, and it'll go back through, right? But this was first try, here it is, and we can see, and it works, right? And then like what exactly it's doing to me is insignificant in that it's able to perform and do this complex matrix multiplication on the first try without any sort of like inputs or any sort of errors whatsoever. Whereas every single time that I do use ChatGPT at like the base for PSO or algorithms, like it's always a back and forth. Right? I get used to that back and forth. So like not having that back and forth is intriguing to me and sticks out. And then so only difference with this model is, again, it's just RAG tuned on the data set, right? Here's the output from the model here for in the PSO swarm. I ask it for the PSO swarm algorithm, and just, for demonstration purposes and to play around with it. And it's really cool as to the outputs. So kind of the bottom line here to me is I think there's a lot of value and a lot of play within thinking outside of the box when it comes to these models and interacting with these models. They operate in strange ways that we don't understand, and they relate concepts to the world and about the world and about everything that is related to that in ways that we don't understand or ways that we wouldn't inherently or intuitively do. Right? So creating concepts for LLM models like Python chemistry, in my experience and in my mind, will be much more, it will set the world further ahead and set AI further ahead than trying to like create another 10 million row data set of Python. We already have a 10 million row data set of Python, right? But creating something that's unique outside of the box and that takes advantage of the fact of how LLM models like how they world build, right? And they world build essentially off of patterns between words and between concepts. And so take that and then utilize that. And then so if there happens to be a pattern in that world between chemistry and Python, then why not? It seems to me a pretty valid pattern, and it works out pretty well if you just run with it. And then so pretty cool developments in this scenario here. If you like this type of content, please like and subscribe. Thank you very much.